So we are talking generally about relations between sets of numbers, or specifically one number in the first set. We call the first set the domain, the numbers you put in, and paired with numbers in the other set, the range, the numbers that come out. And we specifically will be referring to the domain as the x value, the number in is the x value, and the range as the y value, right? Then really the range is all the set of all of the numbers that come out, okay? So the domain is the set of x values, everything that you put in, and the range is everything that comes out, okay? You could either be given specific x values that you put in, or you could say just anything that makes sense or is allowed to go in, okay? And then the resulting numbers that come out when you plug those numbers in, okay? A function is a special type of relation in which each value in the domain is paired with exactly one value in the range. And you'll recall me saying this, where you have, let's say a Coke machine, this button, this number in, right? The button is the number in, the entry that you push should only produce one thing out. You should only get a Coke when you push this button, right? Special type of relation in which the value in the domain, this button, is paired with exactly one value in the range, a Coca-Cola specifically, okay? This button can also produce a Coke, but these buttons shouldn't produce anything but that, right? There's only one thing coming out for that input value. And that's the idea of a function. Special type of relation. Things can be relations, not necessarily functions if they don't meet that requirement, okay? Let's see where we're going with this. Here you are introduced to mapping diagrams, and mapping diagrams show a group of domain values and then a group of range values, and they connect them, okay? Identify the domain and the range in each relation. Represent the relation with a mapping diagram, and is it a function? Okay, so recall what I said, that every x value is part of the domain and every y value is part of the range. So what we're going to do is we're going to separate all of these x values out, and we're going to put them in a group, and we're going to separate all these y values out and put them in a group, and then we'll draw lines to connect them. Same thing with here. Take all the x values, put them in the domain group. All the y values, put them in the range group. Here's what it looks like when you do that, okay? We have -2, 0, 4, and 5 for the domain, okay? What do we get out? 0.5, 2.5, 6.5, and notice that we get 2.5 again. We're only going to write it once. And then we say, okay, what goes with what? Well, -2 produces 0.5, so you put an arrow there. 0 produces 2.5, 4 produces 6.5, 5 also produces 2.5, so you have them pointing both to this range value, okay? Each domain value, each number over here, is mapped to only one range value. Like, for example, 5 is only pointing to that. 0 is only pointing to that. So this is a function. Over here, all of the domain values, 6, 4, 6, and 5, we'll put them in order, 4, 5, 6, okay? 4 produces 3 right there, so you put an arrow there. 5 produces 8 right there. And 6 produces both 4 and 5, okay? The domain value 6 is mapped to two range values. It's splitting into two. This is not a function. You're going to identify the domain and range of each and draw it as a mapping diagram. You're going to do it just like you see here, where you write domain and all the values inside, range values inside. You only write each value once, put an arrow pointing to each one, and then identify if it's a function. Now, something that you would have noticed if you graphed the earlier points just as individual points on a graph, you would have noticed that for the one that's not a function, there are 2 points that are directly above one another. They both have the same x value, and they just have different y values. So they would be points that were directly above each other on the graph. And this is describing what you can do as a quick way of identifying whether it's a function or not. You can decide if a relation is a function by analyzing the graph of the relation using the vertical line test. If any vertical line passes through more than one point on the graph, then for some domain value, there is more than one range value, so it's not a function. Check out what this looks like here, okay? Identifying this using the vertical line test, okay? Is the relation a function? So what you're gonna do is you're gonna graph these points, and we're going to examine it with the vertical line that I have over here to the right in pink. You'll also graph this, and we'll do the same thing for that. So here's the first one, okay? All of the points are graphed. For example, negative 4 comma 2, you start at the origin, you go over to negative 4, and you go up to 2. That's right there, okay? Now watch what happens if you take the vertical line and you slide it over here. You see it going through 2 points at once at that particular value of x equals negative 4. And that's because you see here negative 4 produces both 2 up here, and here negative 4 produces negative 1 down here. So the vertical line shows, oh, look, it's going through 2 points at once. That's got to be not a function. And that's what it says right here, not a function. If we were to graph this next one, and we take this vertical line and we move it over top of it, there is no point where the vertical line goes through the curve more than once, okay? And that's what this says right here. There's no vertical line that passes through more than one point on the graph at the same time, so the relation is a function, okay? And you're going to do the same for these values right here. Oops. Okay, plot them individually on a graph and then take a vertical line and see if any of them go directly through both points at the same time, and if they do, it's not a function. Now, I've referred to this in class. You might have an equation such as y equals negative 3x plus 1, and it relates x to y, or the input value to the output value. This same equation here is written using function notation, where f of x just represents the output, just like y represents the output. So you'd say the function applied to the value x would be negative 3 times that value x plus 1, okay? So notice that f of x replaces y, and it is read f of x. The letter f is the name of the function, and it's not a variable. We're just saying this function f, the function rule applied to this, okay? Function notation is used to emphasize that the function value f of x depends on the independent variable x. And if you had more than one function at the same time, you would see g of x and then h of x. That's very common, okay? So what do we do with it? Well, they say the function w of x equals 250. X represents the number of words, this is the output number, that you can read in that many minutes. You put the input number in and it produces a value out. How many words can you read in 8 minutes? Well, the way that you write it is you would say, if you're going to evaluate it for x equals 8, then where you see x here, you write 8. So you would write w of 8, and then you would have the value of it. So if w of x generally is 250 times x, then w of 8, or that function value w applied to the value 8, is 250 times 8. If you replace x with 8 here, you replace x here with 8 as well. Then you do the math and you say w of 8 equals 2,000, so you can read 2,000 words in 8 minutes. Okay, let's see how you do with this one. Apply that same rule. How many words can you read in 6 minutes? Now, finding the range. They give you this function, f of x equals negative 1.5x plus 4, and they say the domain of that is these numbers. These are the 4 numbers that you are putting in, okay? So what is the range? What numbers would come out when you plug in 1, 2, 3, and 4? And essentially what you would be writing is f of 1 equals negative 1.5 times 1 plus 4. F of 2 equals negative 1.5 times 2 plus 4. And you would calculate, you do that over for all 4 numbers and calculate them out. That's what it looks like. There's the function values you're putting in, and so this is the expression that f of x is equal to, so you plug in those numbers individually, 1, 2, 3, 4, and it produces these numbers out as an output value, or a range is what you'd call the entire set. So which number up top represents that? Well, it appears that A does. Okay, has those exact numbers. So this is the range, and the correct answer is A. Now apply that same understanding here. The domain of this function, g of x equals 4x minus 12, is this. This is the domain. These are the numbers that you will be plugging in one at a time. What is the range? What is the set of values that comes out? So if you have 3 quarts of paint to paint the trim in your house, and a quart of paint covers 100 square feet, then what you have here is a function, the area covered by q quarts of paint, or A of q, equals 100 times q, where the area is A of q represented in square feet, and q is the number of quarts that you have of paint. Okay, so what domain and range are reasonable for the function, and what is the graph? So the first thing you've got to think of for the domain is, because this is a whole, there's not individual points, but this is a whole range of numbers written like as an inequality. It's got to be greater than this, less than this. And so you have to think logically about what's the least amount that you could paint and what's the greatest amount. So if you say 1 quart of paint covers 100 square feet, you have 3 quarts of paint. That's helpful. Okay. A reasonable domain and a range values is what you need in order to be able to graph it. Okay. And so the plan is to find the least and the greatest amounts, and then we can use those as endpoints and we can make our graph. So what can we do? Well, the least we could use is none, obviously. So the Q, the number of quarts we use, could be 0 or greater than 0. Okay, and you only have 3 quarts of paint, so the most you can use is 3, but you could use 3, so that's number of quarts you use has to be less than or equal to 3. So this is what you get for the domain. And you can see that since it's a whole span of numbers, that you write it as an inequality. Okay, so to find the range, we evaluate the function using the least and greatest values. If you used 0, you would paint 0 square feet, and if you used all 3 quarts, you would paint 300 square feet of the wall. So the range is A of Q is greater than or equal to 0 and less than or equal to 300. So to graph it, we need to make a table of values to have some points. So what if you used 0 quarts, 1 quart, 2 quarts, and up to 3 quarts is the limit that you've got, right? And then that would look like that. And you can see that it's a connected line because everything in between those individual points also makes sense. You could paint any amount from 0 to 3. Those would be the resulting output values. Okay, try it with this one. If you have 7 quarts of paint, what are the domain and range that's reasonable for problem 5? So you're going back to this idea up here, and you're saying, what if you had 7 quarts of paint? Now it says, why does it not make sense to have domain values less than 0 or greater than 3 for the original problem? See if you can answer all of those questions before you check your work. Okay, there are several new concepts in here, but they all are very logical once you work them a little bit. So work these problems out and see how you do.